Hey, how you doing? Welcome back to the world of physics. In this video, I want to talk about one recent paper that we published on physics education research. I did this work when I was at Carleton College, but the writing process took place at Eastern Washington University. Some concepts taught in introductory physics courses in college can be non-intuitive, but with practice, students can develop skills to satisfactorily solve typical numerical problems without having the concepts totally clear. One educational tool efficient to settle abstract concepts is learning by teaching, where students are asked to teach what they have learned to younger students. So, we have developed a project which I incorporate in the syllabus of an introductory physics course in college. The project consists on the making of an educational video aimed at high school students as a way to deepen the understanding of classical physics and also special relativity concepts. Some faculty are using videos as a way for students to present their homework. Some others are using that as a way of presenting some research they do. What we do is to first have college students create an educational video. This way they not only learn physics, but how to structure their learning to communicate it in a satisfactory manner. And second, they get to present it to high school students, so they get feedback on their job. This way, they can not only have the experience of teaching and communicating to others, but also to detect what worked and what didn't work in the presentation of that abstract concept that they chose. Instead, students were 90% first-year college students. Most had taken physics in college, but most didn't take AP, Advanced Placement Physics. Of course, the video is an evaluated assignment. For this, there is a clear rubric to help them focus when creating the video. Students also create some questions to ask to the high school students. This is a way to quantify in some form the impact of the video on those students. There are just two true and false questions that students have to answer before and after watching the video. Students might change their opinion after watching the video. College students need to choose one concept, one idea, included in the context of the course they are taking. There is a scaffolded schedule of what they need to have accomplished each week of the course, where the last week is the week of presenting their work in the local high school. When the topic used was special relativity, the topics selected were from a list of paradoxes that they had to choose from. They had to solve the paradox numerically and explain it.
Imagine that you're traveling at 60% the speed of light.
What would you look like to someone on Earth?
You just look the same, right?
Wrong.
Most of the topics had been covered in more or less depth by the high school students. So, in principle, they should answer the true-false questions correctly before watching the videos. That was not the case for all answers, but there was a clear improvement in the answers after watching the videos. Most of the correct answers remain being correct. After the video, most of the wrong answers changed to correct, and a very few of the initial correct answers turned into wrong. That happened for the most abstract topics such as moment of inertia and Doppler effect. The corresponding videos are later analyzed by students, and they find many places for improvement to make them more clear, more transparent, which probably is also indicating where the college students got a poorer understanding of the topics. Of course, there's always the doubt of where the improvement in the answers come from. Is it due to the fact that the video acts as a reminder, a refresher of the physics they had already studied? Is it coming from the quality of the videos? In order to answer this, I want to run the project again, but with students that will answer the questions sometime probably a week before watching the videos and same time 1 week after watching the videos. Another thing that would be interesting to do is to have a control group that spends the same amount of time, instead of watching the videos, just reading that part of the textbook, and then both groups answer the questions. With this project, we intend to have college students reflect on the role of teaching and on how that can benefit their own learning. In the process of developing the video, they were required to solve a particular problem in physics, but also to explain it to a person with less background in physics than they have. This makes the students structure their ideas and find an efficient way to address them, using analogies and examples. This requires the additional effort to comprehend the abstract concepts they are presented. They are also asked to show their draft video to friends and family before editing the final version. By doing this, they realize which aspects are unclear to their audience, which could be because of the way they present their topic in some cases, but could also be because they did not have a clear idea of the physics that were presented. Overall, we observe an improvement in the answers from the high school students at the end of the project and a good feedback from them. We think this is a positive experience and shows the beneficial impact we were anticipating. On one side note, it is worth mentioning that this learning by teaching project with YouTube videos that links high school with college can be easily extended to other age groups, in particular in the same institution, reducing that way the coordination issues that might arise when two different institutions are involved. Schedules, semesters versus trimester system, mobility of students, etc. High school students could develop educational videos for middle school students, or senior students could do the same for sophomore students, for example. Also, it's worth mentioning that most colleges and universities have a Center for Community Engagement that can facilitate the coordination with other institutions of community or community groups. May the saints be with you.